Okay, everybody, let's get into our study of trigonometry here. And basically, with trigonometry, there's a couple big topics. It has a lot to do with triangles. You can do a bunch of things with right triangles, which we're going to do now. Then there are also some things that are done with non-right triangles. You know, just any old random triangle. And then it can also be extended to circles. You know, you can have angles larger than 180 degrees. And there's a lot of trig that goes on there too, so that's a little more advanced, and we will get there down the road. What I want to start with on day one here on our first intro piece is just finding the length of sides in triangles, and let's just focus on right triangles. So let's just make sure we have a couple of the basics down. So just in any old right triangle, you have two legs, and then you have a long side, which is called the hypotenuse. Okay, so let's just say we have leg 1 and leg 2 and then the hypotenuse. And generally you'll have to know at least one of the sides, and then you can do some things to find the other one. So, of course, the old standby that hopefully everyone's familiar with is our old buddy Pythagorean Theorem, who says that if the legs are A and B, and then the hypotenuse length is C, we all have heard that A squared plus B squared will equal C squared. Okay, and that works every time as long as it's a right triangle. Just making sure that your C or hypotenuse is the one that is on the equation on the side by itself, and that the two legs, it doesn't matter which one's A and B, just leg 1 and leg 2 are the two that get added together. And don't forget to square them, and you can usually just solve those pretty straightforward with a calculator. Okay, but what I want to talk about, what if we don't know two lengths, right? Because to solve this equation, to solve Pythagorean's equation, there can only be one unknown, right? A squared plus B squared equals C squared, so you have to know 2 out of the 3. But let's take a look at another case and think about how would we go about solving things if we only knew one of the sides. Okay, so there is some stuff going on with trigonometry, like I said, and let me just draw a little right triangle here. Let's say that is the right angle there. And we have the 3 side lengths again. We have the hypotenuse over here. We have a leg here and a leg over here. Okay, and actually there are these trig ratios that kind of talk about, you know, how long the legs are in relationship to the hypotenuse, or how long they are in relationship to each other. And those 3 trig ratios you may have heard are called sine, cosine, and tangent. So let's just talk about what those are, and then we'll do a couple examples of how to solve them. Okay, so again, we have sine, we have cosine, we have tangent. Okay, and those are the abbreviations for the 3. Now, it's going to depend on which angle we're talking about, right? We have an angle here and we have an angle here. So let's just say we're using that angle there. So that symbol is a Greek letter, theta, and it's generally used for angles. So if you see it, chances are it's going to be, referencing an angle measure. And basically what happens is we have these ratios, and it's going to compare any 2 sides of the triangle. So there is a certain order, okay, and you guys may be familiar with this. I know this is probably not the first time you're seeing it, so it should be somewhat familiar, but there's this little Sohcahtoa, a little memory device on how to remember what each of these ratios stand for. So the way it works, the S, C, and T, those are the first letters of sine, cosine, and tangent. Okay, and then the other letters are telling you which sides of the triangle, and they're in order. You'll see in a second, and it tells you which side of the triangle it deals with. Okay, so for example, for where I put theta in this spot over here in the bottom right corner, the leg all the way across the triangle, all the way over here, that would be known as the opposite leg. Okay, it's all the way across the triangle. And then the other leg, the leg that's actually connected to the angle, is known as the adjacent. And then the hypotenuse is just the hypotenuse. It's off by itself. Okay, so you're going to want to make sure you look and know which angle you're kind of dealing with, because the issue is, if we were talking about this angle, then the opposite angle would now be, the opposite side would be down there. So it's definitely very important as to which angle you're dealing with. And in some problems, you'll have more than one angle, so you'll have to choose and just set it up properly. Okay, but let's just get these equations filled in and then do a couple examples. But again, the sine of any angle is going to be if you look in the formula or the memory aid, you know, for sine, Sohcahtoa is O over H. So it's going to be the opposite length over the hypotenuse. Okay, cosine A over H, so adjacent over hypotenuse. And then tangent is O over A, so opposite over adjacent. Oops, we're running out of room down there. Let's fit that in, okay? So let's get some numbers in. Let's set up a problem and see what this is all about. Okay, so let's say we have a little triangle like this. Let's just draw it over here. Here's my right angle. This time, let's say we're given an angle of 62 degrees. And let's say we know this side length down here is 10. And they are asking us to find the hypotenuse length. Okay, so we need to figure out the length of the hypotenuse. And we know only one side, right? So Pythagorean Theorem's out the window. I don't know this other side over here, and honestly, we don't even need it, okay, for this problem. All I'm interested in is finding x, but it's worth looking at. If we knew that side, it'd probably just be easiest to use Pythagorean Theorem. But we don't, so let's not even worry about it. So what we need to ask ourselves, we need to think about, based on this angle's location, what side lengths are we dealing with? Okay, so again, the one way across the triangle here, that is always the opposite side length. Okay, which one's the x? It's across from the 90, so that's actually probably the best one. Label that first, just get that one out of the way. The hypotenuse is x, and then so 10 must be the adjacent leg, because it's connected to the angle. There's our 62-degree angle. It's one of the sides of the angle, but it's not the hypotenuse, so it will always be the adjacent. Okay, now I'm not worried about the opposite side in this problem, right? It just does not matter. So if you think about Sohcahtoa, one of those will not have anything to do with the opposite side. Okay, so if we take a look, the only one that doesn't need the opposite side is going to be cosine, right? Because the other two, you need to know the opposite side. It's part of the problem. So we're going to use cosine, and we're going to write ourselves an equation. When you write sine, cosine, or tangent, you always say of some angle measure, okay, or theta if we don't know it. And now we know that the cosine of any angle is always A over H. So the adjacent side, which is 10, over the hypotenuse, which is x. So you end up writing an equation, okay? You need to be writing an equation for all these. And the way we're going to solve it is you're going to have to use a calculator, okay? The cosine of 62 degrees is just some decimal. Like, your calculator knows what it is. And make sure, double check, before you even do these problems, go into the mode. Make sure you're in the proper mode. For now, we're using degrees. So if you're doing this on an iPhone or whatever, just Google it, how to know what mode you're in, because it'll mess everything up. If you're in the wrong mode, there's radian, there's degree. Those are the big ones. We'll use radians later. But just figure it out. On the graphing calculators, it's right up next to the second button. Just to the right of that says mode. And when you push that, you'll see a list of different options or whatever, and you'll see radian degree. So make sure degree is highlighted. Okay, and what we want to do, we want to solve this thing for x. Okay, I suggest before you get into the calculator, do your algebra and get x by itself. So what I would do to this equation, since it's 10 divided by x, I would multiply both sides by x. Okay, and that's going to cancel it out over here. So we will have now x times the cosine of 62 degrees equals 10. And now to solve for x, since it's x times something, we are just going to divide both sides by the cosine of 62, okay? Which again, it's just some decimal. Your calculator is going to know what it is. But we're going to get our answer. Let me just clean this up here. X equals 10 divided by the cosine of 62 degrees. So I'm just going right into my calculator. 10 divided by, you'll see the cosine button. It's 2 buttons above the 8. On the TI-84s. 10 divided by cosine 62 is giving me 21.3. Okay, that is our side length here. That's the hypotenuse. Whatever units, 21.3 centimeters or inches or whatever it might be. Okay, so that was one example. Let's set up one more. And again, make sure you have a calculator handy. Really, there's no option on these. There's no way to do them without. Okay, one more example. Let's say we have ourselves a nice little triangle like this guy. We have a right angle here. They're giving us this angle of 38 degrees. The side length we want is down there, and then we know that side is 3. Okay, so see, can we figure out which sides we're dealing with? Is it, which one's the hypotenuse? Okay, the 3 is the hypotenuse, right? That's the one that's across from the 90-degree angle. So that's good. We got that one out of the way. Now we're just left with opposites and adjacents. So the x is actually the one that's connected, right? The 38-degree angle is right there. So the x, that leg down there, is the adjacent leg, right? It's not all the way through on the other side of the triangle where the opposite would be. Okay, so we got everything labeled. And again, just think about Sohcahtoa. Until you get those memorized, maybe just write those down. And then you'll think about, all right, which ones are we dealing with here? So again, our problem, it looks like we don't need the opposite again. That's not part of our problem. So just like the last one, this is going to be another cosine problem. Okay, obviously they're not all going to be that way. But just depending on which sides you're dealing with, which two sides you're using. This one's going to be cosine, so let's write the equation again. The cosine of 38 degrees, okay, it must be the adjacent over the hypotenuse, right? It's a, then h, a over h. So adjacent is x over the hypotenuse, which is 3. Okay, so in this time, since it's x over 3 and we want to get x by itself, you always multiply by whatever's in the denominator. Okay, so that'll cancel the 3 down there. And just be careful, we're not multiplying the 38 by 3. Okay, I'm really multiplying 3 times the cosine of 38. Okay, which again is going to be a calculator problem. So at this step, I'm going right to my calculator. Still in degree mode. I'm doing 3 times the cosine of 38. And it is giving me a value of 2.36. Okay, that's going to be our little adjacent leg down here. Okay, you can kind of check, make sure it makes sense. It's shorter than the hypotenuse, right? The hypotenuse was 3. So just, make sure it seems kind of reasonable. Yeah, that'll solve the problem for us. Okay, let me just set up one last quick one, just since they were both cosine. Let's just say, for example, we needed to solve, let's draw a triangle like this, and let's say we had a 40-degree angle, and let's say we had x and we had 7 or something. Okay, take a second, see if you can get that set up. Okay, so let's think about which sides we're dealing with. Okay, you might want to just label them all. Okay, again, the hypotenuse is over there. In this problem, we don't care about the hypotenuse. It's not really related. So we're just down to the other two. So the x, that side is all the way through, right? That's all the way to the other side of the triangle. So that makes it's the opposite side. It is not the close one. The adjacent means like next to. Right, and you can see those are the two sides formed by the angle. So one will be the hypotenuse and one will be the adjacent. So if we think about our ratios again, our little catchy saying here, which one do we need to use? Okay, our problem is dealing with opposite and adjacent. And there might be some problems where you might have more information. But in this case, we don't know the hypotenuse. We don't really need to know it yet. So I'm not worried about it. So you'll see again, one of the ratios doesn't have an h in it. It doesn't deal with hypotenuse. It's tangent. So I know that the tangent of the angle, tangent of 40 degrees, is opposite over adjacent. Okay, so from our triangle, that's x over 7. And we will simply multiply both sides by 7 to solve for x. 7 times the tangent of 40 will equal x. Again, calculator problem. 7 times the tangent of 40, I'm showing 5.87. Okay, and that would be our, in this case, the opposite side length. Okay, so I hope that helps. Just remember the Sohcahtoa setting or saying. Label the pictures. They really, really help, especially at first, and show your steps. Okay, there's a lot of issues sometimes with steps, and the trick usually is just generally multiply by whatever's in the denominator. Okay, and that'll help clear that fraction for you.